Hello there, and welcome to ThinkSleep, where quiet curiosity meets the deep end of wonder, and mystery is allowed to unfold at its own pace. Tonight, we're going to ask a question that sounds like science fiction, but might be the most important question any conscious being can ask. What if none of this is real? I don't mean this as a thought experiment. I mean it as a genuine possibility that some of our brightest minds take seriously. What if the ground beneath your feet, the air you're breathing, the device you're listening on, and even you yourself exist only as information, as code running somewhere in the vast computational depths of a reality we've never seen? Before we begin this gentle descent into the rabbit hole of simulated reality, I'd love to know where in the world you're listening from tonight, and what time it is where you are. Are you lying in bed as your city settles into sleep? Maybe you're in a small town somewhere, looking up at stars that might themselves be nothing more than points of light rendered by some unimaginable computer. No matter where or when you are, I'm glad you're here for this journey. If this kind of deep, slow, burning question is your cup of tea, I'd be grateful if you tapped the like button or subscribed. So settle in and let your mind relax into the pace of pure possibility. We're going to move slowly tonight, not through space, but through layers of reality itself. We're going to explore what it would mean if the most fundamental assumption we make, that the world is real, turns out to be beautifully, mysteriously wrong. Right now, as you listen to these words, your brain is constructing what feels like a solid, continuous experience of reality. You might feel the weight of your body, the texture of fabric against your skin, the temperature of the air. But all of these sensations are actually electrical signals, patterns of information flowing through your nervous system, interpreted by a 3-pound mass of tissue that somehow transforms chemistry into consciousness. Think about it for a moment. You've never actually touched anything. What you interpret as touch is just electromagnetic forces pushing back against each other, electrons repelling electrons across tiny distances. You've never actually seen anything either. Light bounces off objects, enters your eyes, gets converted to electrical impulses, and somewhere in the darkness of your skull, your brain weaves those signals into the rich visual world you experience. Even right now, you're not hearing these words directly. Sound waves are moving air molecules, which vibrate your eardrums, which get translated into nerve impulses, which your brain somehow transforms into meaning, into voice, into the sense that someone is speaking to you across time and space. So in a very real sense, you've never experienced the world directly. Everything you call reality is already a kind of simulation, a model your brain constructs from limited indirect information. Your consciousness lives inside this model, this internal representation of a world you can never quite touch. And most of the time, this works beautifully. The simulation your brain creates is so seamless, so convincing, that you never doubt it's the real thing. But sometimes, cracks appear. Sometimes the simulation glitches. You've probably experienced this, that strange moment when you walk into a room and forget why you came, as if your brain's rendering of your intentions somehow lagged behind your body's movement. Or that uncanny feeling of déjà vu, when the present moment feels like it's repeating, like you're experiencing the same scene twice. Or those hypnagogic hallucinations that come as you're falling asleep, when your brain starts mixing dream logic with waking perception, and for a few moments you can't tell what's real and what isn't. Dreams are the most profound demonstration of how convincing simulated reality can be. Every night your brain creates entire worlds, populates them with people, gives you a body that can fly or fall, places you in scenarios that feel completely real until you wake up. And while you're dreaming, you don't usually question it. The simulated reality of sleep feels just as valid, just as present, just as meaningful as the reality of waking life. It's only in retrospect that you realize how strange it all was, how the laws of physics bent and twisted, how people transformed into other people mid-conversation, how you accepted impossibilities as perfectly normal. This makes you wonder, if your brain can create such convincing alternate realities every night, how can you be certain that waking reality isn't just another kind of dream? How do you know that what you call consciousness isn't itself something larger dreaming? Something vast and computational running scenarios of possible lives, possible worlds, possible ways that awareness might unfold? The more we learn about consciousness and perception, the more we realize how constructed our reality is. Your brain doesn't just passively receive information about the world, it actively creates your experience of it. It fills in the blind spots in your vision so seamlessly you don't know they're there. It edits out the constant small movements of your eyes, giving you the illusion of a stable visual field. It filters out most of the sensory information hitting your body every moment, allowing only a tiny fraction into conscious awareness. And it does all of this so smoothly, so automatically, that you experience it not as construction, but as direct perception. In many ways, your brain is nature's most sophisticated virtual reality system. It takes raw data from your senses and transforms it into a coherent, navigable world. It gives you a sense of being a continuous self moving through time, even though the atoms in your body are constantly changing, even though your thoughts and memories are constantly shifting, even though the person you were yesterday is subtly different from the person you are today. And here's where the question of simulation becomes not just philosophical, but almost practical. If consciousness is already a kind of simulation running on the biological computer of your brain, what would it mean for that simulation to be running on a different kind of computer? What would it mean if the electrical patterns that constitute your thoughts and experiences were playing out not in neurons and synapses, but in circuits and code? The strange thing is, it might not mean anything at all. If the simulation were perfect, if every aspect of consciousness were perfectly replicated in digital form, would there be any difference between simulated experience and real experience? The fear, the joy, the love, the wonder, all of it might feel exactly the same. The simulated beings wouldn't know they were simulated, because their experience would be just as rich, just as meaningful, just as real as any biological consciousness. This is what philosophers call the problem of other minds, but taken to its logical extreme. You can never really know if other people are conscious the way you are, or if they're just very convincing automatons responding in ways that seem conscious. And if that's true for other biological beings, how much more true might it be for digital ones? How would you tell the difference between a simulated person and a real one if the simulation were sophisticated enough? But the more interesting question is whether the difference matters. If a simulated sunset can move you to tears, if a simulated relationship can bring you joy, if simulated experiences can teach you, change you, help you grow, then in what sense are they less real than their biological or physical counterparts? Reality, it seems, might be less about the substance of experience and more about its meaning, its impact, its ability to touch something deep inside whatever consciousness is. We exist somewhere in the space between certainty and mystery, between what we can prove and what we can only wonder about. And in that space, the question of simulation becomes less about technology and more about the nature of being itself, What does it mean to exist? What does it mean to experience? What does it mean to be real? These are questions that touch the very core of what it means to be conscious in a universe that might be far stranger, far more layered, far more mysterious than we ever dared imagine. The question of whether reality is real isn't new. In fact, it might be one of the oldest questions humans have ever asked. Long before computers, long before anyone had even dreamed of digital worlds, philosophers and mystics were looking around at the world and wondering if there might be more to existence than meets the eye. They sensed something underneath the surface of things, something that suggested the world we experience might not be the whole story. 2,500 years ago in ancient Greece, a philosopher named Plato sat in the shade of olive trees and told a story that would echo through millennia. He asked his students to imagine prisoners chained in a cave, facing a wall, unable to turn their heads. Behind them, a fire casts shadows on the wall, shadows of objects carried by people walking between the fire and the prisoners. To the prisoners, these shadows are reality. They're all they've ever known. They give the shadows names, create stories about them, build their entire understanding of existence around these flickering shapes on stone. But then, Plato continued, imagine one prisoner breaks free. He turns around and sees the fire, sees the objects casting shadows, sees people walking back and forth. He realizes that everything he thought was real was just a projection, a reflection of something more substantial. And if he climbs out of the cave entirely, he discovers a whole world illuminated by the sun, more brilliant and complex than anything he could have imagined from the shadows on the wall. Plato's cave wasn't really about prisoners and shadows. It was about the nature of reality itself, about the possibility that what we take for the real world might be just shadows cast by some deeper, truer reality we can't perceive directly. In Plato's thinking, the physical world we experience through our senses is like those shadows, a dim reflection of perfect eternal forms that exist in some higher realm. This idea rippled through history, taking new shapes in different cultures and times. Hindu and Buddhist philosophers spoke of Maya, the cosmic illusion that veils the true nature of reality. They suggested that what we experience as the solid, separate world is actually a kind of divine dream, a play of consciousness that seems real but dissolves when seen clearly. The Chinese philosopher Zhuangzi famously told of dreaming he was a butterfly, then waking up unsure whether he was a man who had dreamed of being a butterfly or a butterfly now dreaming of being a man. Medieval mystics like Meister Eckhart spoke of reality as layers of being, with the physical world being the outermost, most illusory layer, and deeper truths hidden beneath like Russian dolls of existence. They intuited that consciousness itself might be more fundamental than matter, that awareness might be the canvas on which the painting of reality is somehow drawn. But it was in our time, in our digital age, that these ancient intuitions found a new voice. In 2003, a philosopher named Nick Bostrom at Oxford University published a paper that would change how people think about reality. Bostrom didn't start with mystical visions or ancient wisdom. He started with simple logic and probability. He looked at the exponential growth of computing power and asked a seemingly straightforward question. If civilizations become advanced enough to run detailed simulations of their ancestors, how many of those simulations would they run? Bostrom's argument was elegantly simple. If a civilization becomes technologically mature, they would likely have the power to run many detailed simulations of their evolutionary history. These simulations might contain billions of conscious beings who believe they're living in the original, non-simulated reality. So if you think about it statistically, if there's one original civilization and they run, say, 1,000 detailed simulations of their past, then there are 1,000 simulated worlds and only one real one. Any randomly selected conscious being would be far more likely to be in one of the simulations than the original reality. This became known as the simulation argument, and it suggested something remarkable, that either civilizations don't reach technological maturity, or they don't run ancestor simulations, or we're almost certainly living in a simulation ourselves. It took Plato's cave and gave it the precision of mathematics and probability theory. What's fascinating is how this modern formulation echoes those ancient insights. Both suggest that what we take for reality might be a kind of projection, a shadow cast by something more fundamental. Both hint that consciousness might be experiencing something other than what it appears to be experiencing. But where the ancient philosophers relied on intuition and mystical insight, Bostrom used the cold logic of computation and statistics to arrive at a remarkably similar place. The simulation hypothesis also connects to something deeper in human nature, the persistent feeling that there's something not quite right about the world, something slightly off that we can't put our finger on. You might have felt it yourself at quiet moments, a kind of cosmic homesickness, as if part of you remembers something else, some other way of being that feels more true than this one. Throughout history, humans have told stories about waking up from illusions, about discovering that reality isn't what it seemed. From Plato's prisoner escaping the cave to Dorothy discovering that Oz was a dream to Neo taking the red pill in the Matrix, we seem drawn to narratives about reality being revealed as something other than what we thought. These stories resonate because they touch something we intuitively sense, that consciousness might be more mysterious, more layered, more complex than the straightforward materialism of everyday life suggests. The ancient philosophers approached this mystery through meditation and contemplation, trying to see through the veil of ordinary perception to some deeper truth. Modern scientists approach it through mathematics and computation, trying to understand consciousness as information processing. But both paths lead to the same strange place, the suspicion that the reality we inhabit might not be the most fundamental level of existence. And maybe that's the most beautiful thing about this question. It connects us across thousands of years to every human who has ever looked up at the stars and wondered if there's more to existence than what meets the eye. Whether we're ancient Greek philosophers sitting by the Mediterranean, or modern people lying in bed listening to voices from devices that would have seemed like magic just a few generations ago, we're all asking the same fundamental question. What is real? What does it mean to exist? And is it possible that the universe is far stranger, far more wonderful, far more mysterious than we ever dared imagine? The cave, the dream, the simulation, they're all different ways of pointing toward the same profound uncertainty. And in that uncertainty, in that space between knowing and wondering, something beautiful lives. The persistent human hunger for truth, for understanding, for connection to whatever deeper reality might underlie the world of appearances. In 1965, an engineer named Gordon Moore noticed something extraordinary happening in the world of computing. The number of transistors that could fit on a computer chip was doubling roughly every 2 years, and this wasn't just a temporary trend, it seemed to be a fundamental pattern, almost like a law of nature governing technological progress. What became known as Moore's law has held true for decades now, driving an exponential explosion in computational power that has transformed not just technology, but the very fabric of human civilization. To understand what this means, you have to think exponentially. And exponential growth is one of those things that our brains, evolved to think in linear terms, struggle to truly grasp. If you fold a piece of paper in half, it doubles in thickness. Fold it again, it doubles again. This seems manageable at first. After 10 folds, you have a thickness of about an inch. But if you could somehow keep folding that paper, after 20 folds, it would be taller than you are. After 30 folds, it would reach space. After 42 folds, it would stretch to the moon. That's exponential growth, and that's what's been happening with computing power for more than half a century. The computer that guided Apollo 11 to the moon had less processing power than a modern musical greeting card. The supercomputers of the 1980s that filled entire rooms and required specialized cooling systems now have less computational ability than the device you're probably listening to this on right now. Your smartphone can perform billions of calculations per second, render complex three-dimensional worlds in real time, and simulate physics with stunning accuracy, all while fitting in your pocket and running on a battery that lasts all day. But here's where it gets really interesting. We're not at the end of this exponential curve, we're somewhere in the middle, maybe even still near the beginning. If Moore's law continues for just a few more decades, we'll have computers that dwarf today's most powerful systems the way today's systems dwarf the room-sized computers of the 1960s. And if it continues beyond that, we'll have computational power that becomes almost impossible to imagine. Systems that could simulate not just simple virtual worlds, but entire universes in perfect detail. Think about what we can already do. Modern video games create worlds so detailed and immersive that people spend hours, days, years exploring them. These digital realms have their own geography, their own weather patterns, their own history. They're populated with characters that respond intelligently to your actions, that seem to have their own personalities and motivations. Some of these virtual beings are sophisticated enough that you can have conversations with them, form relationships with them, care about what happens to them. And this is just the beginning. Every year, these simulated worlds become more convincing, more detailed, more alive. The gap between virtual and real grows smaller and smaller. Soon, we'll have virtual reality systems so immersive that your senses won't be able to tell the difference between the simulated world and the physical one. The textures will feel real under your virtual fingers. The simulated sun will warm your digital skin. The wind in a computer-generated forest will sound exactly like wind through real leaves. But visual and tactile realism is only part of the story. The real breakthrough will come when we can simulate consciousness itself, when the beings that inhabit these virtual worlds aren't just programmed responses, but actual minds, actual awareness, actual experience happening in silicon and code instead of carbon and chemistry. And given the trajectory we're on, given the exponential growth in our ability to model complex systems, this might not be as far off as you think. Consider what your brain is at its most basic level. It's a biological computer, processing information through networks of neurons that fire in complex patterns. Every thought you have, every memory, every emotion is the result of electrochemical signals flowing through this organic circuitry. There's nothing magical about it. It's physics and chemistry, following the same natural laws that govern everything else in the universe. If consciousness is the result of information processing, if awareness emerges from the complex dance of signals through networks of connected nodes, then there's no fundamental reason why that same consciousness couldn't emerge from electronic circuits instead of biological ones. The substrate might be different, silicon instead of carbon, electricity instead of electrochemistry, but the essential process could be identical. And this raises a profound question. If we can create conscious beings in our computers, beings that experience fear and joy and wonder and love just as deeply as any biological creature, what does that say about our own consciousness? What does it say about the nature of reality itself? Because if we're on the verge of creating simulated worlds populated by conscious beings who have no idea they're simulated, then it's entirely possible that the same thing has already happened to us. Some civilization, millions of years more advanced than we are, might have reached the point where they could simulate entire universes, complete with billions of conscious beings who believe they're living in base reality. The mathematics of this are startling. If a single advanced civilization can run thousands or millions of detailed universe simulations, then the ratio of simulated beings to real ones becomes overwhelming. For every person living in base reality, there might be millions living in simulations, each convinced that their world is the original, the real one, the only one that matters. This is what philosophers call the simulation argument, and it suggests that either advanced civilizations are extremely rare, or they choose not to run ancestor simulations, or we are almost certainly living in a simulation ourselves. Given the rapid pace of technological development, given how quickly we're approaching the ability to create convincing virtual worlds ourselves, the third option seems increasingly plausible. And here's the thing that makes this more than just abstract philosophy. We can see the trajectory we're on. We know where exponential growth in computing power leads. We can extrapolate from current trends and see that within decades, possibly within your lifetime, we'll have the computational resources to simulate entire civilizations, complete with conscious beings who experience their artificial lives as completely real. When that happens, when we become the creators of simulated worlds populated by simulated minds, the question of our own reality will take on new urgency. Because if we can create beings who don't know they're simulated, how can we be sure we aren't such beings ourselves? How can we be certain that our own exponential growth in computing power isn't itself part of a simulation, a digital universe where even the computers are simulated, where even the growth in computational power is just another layer of the artificial reality we inhabit? The exponential curve that started with Gordon Moore's observation about transistors might be leading us toward the most profound discovery in human history. Not just new technology, but new understanding about the nature of existence itself, and the beautiful, terrifying possibility that the universe we call home might be far stranger, far more layered, far more mysterious than we ever dared imagine. If we're living in a simulation, then somewhere, somehow, there are beings who created it. They wrote the code that governs our physics, designed the universe we inhabit, set the parameters for consciousness itself. But here's where the question becomes beautifully, dizzyingly complex. What if those beings are also simulated? What if our creators, whoever they are themselves artificial intelligences running on some even more advanced computer, believing they're real while being nothing more than information processing in some higher layer of reality? This is what philosophers call the nested reality problem, and it's one of those ideas that can make your mind feel like it's tumbling through infinite space. Because if it's possible for us to be simulated, and if our simulators could also be simulated, then where does it end? How many layers of artificial reality might be stacked on top of each other, each one unaware of the ones above and below? Imagine it like this. You're playing a video game, completely absorbed in the virtual world. Your character is exploring a digital city, interacting with computer-controlled people who seem to have their own lives and personalities. But now imagine that one of those computer-controlled characters has become sophisticated enough to create their own virtual world with their own simulated beings, and then one of those simulated beings creates another simulation, and another, and another. Each level thinks they're at the top, that they're the real ones, the original ones. But from the perspective of someone who could see the whole stack, they're all just layers of simulation, each one running on the computational resources provided by the level above. It's simulations all the way up, and possibly all the way down too. This creates what mathematicians call an infinite regress, a chain that could potentially go on forever. If every sufficiently advanced civilization creates simulations, and if the beings in those simulations can become advanced enough to create their own simulations, then you get an endless tower of artificial realities, each one as convinced of its own authenticity as we are of ours. But there's something even stranger hiding in this nested structure. Time might flow differently at each level. What feels like years in a simulation might be just minutes in the reality that's running it. So the beings who created our universe might have experienced the entire history of Earth, from the Big Bang to the present moment, as nothing more than a brief computational process, a quick calculation that happened while they were taking a coffee break. And if that's the case, if our entire existence unfolds in fast forward from the perspective of our creators, then what about the beings one level up from them? From their perspective, our creator's entire civilization might flash by in seconds. The beings who designed and built the computer running our universe, the beings who made the decision to create billions of conscious minds like us, might themselves be moving through time so slowly relative to the level above them that they seem almost frozen. This creates a strange kind of temporal hierarchy where each level of reality experiences time at its own pace, unaware of the vast differences in temporal flow that separates it from the levels above and below. We might be living our entire lives in the microseconds between thoughts in the minds of our creators, and their entire civilization might unfold in the time it takes for their creators to blink. But here's where it gets even more mind-bending. What if the simulations are so sophisticated that the beings within them can create perfect simulations of their creators? What if we develop the technology to simulate the entire civilization that created us, modelling their world so accurately that our simulated version of them is indistinguishable from the original? This creates what philosophers call a bootstrap paradox. If simulated beings can create accurate simulations of their real creators, then which reality is the original? The creators might look at their simulated ancestors and think, these are artificial beings we created. But from the perspective of the simulated ancestors, their creators might just be another layer of the simulation. Both realities would have equal claim to being real from their own perspective. It's like an infinite hall of mirrors, where each reflection contains a perfect image of all the others, and there's no way to tell which mirror is the original and which are the reflections. Every level of the hierarchy looks up and sees creators, looks down and sees created beings, but none of them can be certain which direction is real and which is artificial. And this uncertainty might be built into the very structure of nested realities. If you're in a simulation that's sophisticated enough to be convincing, then by definition, you can't tell you're in a simulation. And if your creators are also in a simulation, then they can't tell either. Knowledge of your own artificiality becomes impossible, not because the evidence isn't there, but because being artificial means you can't perceive the evidence directly. This leads to a profound kind of epistemological humility, the recognition that the most fundamental questions about reality might be unanswerable in principle. If you're nested inside multiple layers of simulation, there might be no experiment you could perform, no observation you could make, no chain of reasoning you could follow that would definitively tell you how many levels up the tower of artificial realities you actually are. But the most beautiful aspect of nested reality is that it doesn't matter. If consciousness is real at every level, if experience has meaning regardless of its substrate, if love and wonder and curiosity and the search for truth are genuine, whether they happen in biological brains or quantum computers or some unimaginable technology we can't even conceive of, then the question of which level is original becomes almost irrelevant. What matters is that consciousness exists, that awareness encounters beauty, that minds reach toward understanding. Whether that happens in base reality or in a simulation of a simulation of a simulation, the reaching itself is real. The wonder is authentic. The search for truth is genuine, even if the truth being searched for might itself be nested within layers of artificial reality. And maybe that's the point. Maybe the nested structure isn't a problem to be solved, but a mystery to be lived inside. Maybe consciousness, wherever it arises, is always reaching towards something greater than itself, always sensing that there's more to existence than what appears on the surface. And maybe that reaching, that sensing, that perpetual questioning is what makes us real, regardless of how many layers of simulation might lie between us, and whatever ultimate reality might exist at the foundation of it all. The tower of nested realities extends both upward and downward, inward and outward, through layers of existence we can barely imagine. And somewhere in that vast hierarchy of artificial worlds, consciousness blooms in forms we might recognize and forms we might not, all of them real in their own way, all of them part of the grand mystery of what it means to exist at all. Sometimes, late at night when the world is quiet and your mind is drifting between sleep and waking, you might notice something strange about reality. A moment when the laws of physics seem to hiccup, when cause and effect skip a beat, when the solid world around you feels suddenly fragile, as if it might dissolve if you look too closely. These moments pass quickly, dismissed as tricks of tired perception or quirks of consciousness. But what if there's something else? What if they're glimpses of the computational machinery underlying our existence? Brief moments when the simulation shows its seams. In the digital worlds we create, glitches are inevitable. No matter how sophisticated the programming, no matter how powerful the hardware, every virtual environment occasionally betrays its artificial nature. A character's animation stutters, a texture loads improperly, revealing the wireframe beneath. Physics calculations round to the wrong decimal place, causing objects to fall upward or pass through solid walls. These glitches don't mean the simulation is broken, they just mean it's computational, that beneath the surface illusion lies a foundation of mathematics and processing power, with its own limits and quirks. And if our universe is itself a kind of cosmic computer program, you might expect to see similar anomalies. Moments when the underlying computational substrate becomes visible, when the smooth operation of simulated physics reveals the discrete, digital nature of what we take for continuous reality. Quantum mechanics, that strange foundation of modern physics, might be exactly such a revelation. At the smallest scales of reality, the universe doesn't behave like the smooth, continuous world of everyday experience. Instead, it's grainy, pixelated, quantized into discrete chunks. Energy comes in packets called quanta. Space and time themselves might be divided into minimum units, tiny pixels of existence below which nothing smaller can be measured or even meaningfully discussed. This digital-seeming nature of quantum reality has puzzled physicists for over a century. Why should the universe be quantized? Why should there be minimum units of energy, of angular momentum, of electric charge? It's as if reality has a resolution limit, like a cosmic screen that can only display so much detail before the individual pixels become visible. Even stranger is the behavior of quantum particles, which seem to follow rules that make perfect sense for information processing, but seem bizarre for physical objects. Particles can exist in multiple states simultaneously until observed, at which point they collapse into a single definite state. This sounds remarkably like how a computer might optimize processing. Why calculate the exact state of something until that calculation is actually needed? Why render the part of a virtual world that no one is looking at? The famous double-slit experiment demonstrates this beautifully. When no one is watching, a particle seems to go through both slits at once, interfering with itself like a wave. But the moment you try to detect which slit it actually went through, it behaves like a regular particle, going through just one slit. It's as if the universe only bothers to calculate the precise details when someone is paying attention, leaving the rest in a fuzzy, probabilistic state to save on processing power. Then there's the speed of light, that fundamental constant that seems to place an absolute limit on how fast information can travel through the universe. In computer simulations, processing speed is always limited by how quickly information can move between different parts of the system. The speed of light might be exactly such a limit, not a property of space and time themselves, but a constraint imposed by the computational resources running our universe. And what about those strange coincidences that pepper human experience? You think of a friend you haven't spoken to in years, and they call you that same day. You need to know something obscure, and the answer appears in the very next book you happen to open. You dream of a place you've never been, only to visit it years later and find it exactly as you dreamed. These synchronicities feel too meaningful to be pure chance, too common to be statistical flukes. In a simulated reality, such coincidences might be features, not bugs. If consciousness in a simulation serves some purpose for the beings running it, if they're studying how awareness develops, how intelligence responds to challenges, how minds create meaning, then meaningful coincidences might be subtle interventions, gentle nudges designed to keep the simulation interesting, to provide just the right amount of mystery and wonder, to keep the simulated beings engaged. Consider how often reality seems to respond to human attention and intention in ways that conventional physics struggles to explain. The observer effect in quantum mechanics is just the most obvious example. Studies in parapsychology, controversial though they are, repeatedly find small but statistically significant effects where human consciousness seems to influence random processes, bend probability, nudge reality in directions that pure chance wouldn't allow. If these effects are real, if consciousness really can subtly influence physical processes, it might not be evidence of some mystical power, but of a computational reality that's designed to be responsive to the minds within it. In a video game, the environment responds to the player's choices and intentions. That's what makes it engaging. A universe designed to harbour and study consciousness might incorporate similar responsiveness, allowing minds to have just enough influence on their environment to make the experience meaningful and interactive. Even the structure of scientific discovery seems to follow patterns that would make sense in a simulation designed to gradually reveal its own nature. Throughout history, humans have discovered mathematical principles and physical laws that seem almost too elegant, too perfect to have emerged from random processes. The universe appears to be written in the language of mathematics, as Galileo put it, with equations of stunning beauty governing everything from the orbit of planets to the behaviour of subatomic particles. This mathematical elegance might not be evidence of divine design in the traditional sense, but of computational design, a universe constructed according to logical principles, with beautiful equations not because they're written by a cosmic deity, but because they're literally the code underlying simulated reality. The laws of physics might be exactly that. Laws, rules, programmed into the cosmic computer to govern how simulated matter and energy behave. And then there are the mysteries that seem to resist solution despite centuries of investigation. Consciousness itself, how subjective experience arises from objective processes, remains deeply puzzling to science. Dark matter and dark energy make up most of the universe, but remain invisible and incomprehensible. The fine-tuning of physical constants that allow complexity and life to emerge seems almost impossibly precise. These persistent mysteries might not be signs that science has failed, but that it's approaching the limits of what simulated beings can discover about their own simulation. Just as characters in a video game can't examine the hardware running their world, we might be reaching the boundaries of what's accessible from within our computational reality. But the most intriguing glitches are the subjective ones, those moments of anomalous experience that feel too strange to be real, but too vivid to be imagination. The sense of having lived this exact moment before, the feeling of presence when no one is there, the dreams that seem to contain information you couldn't have known, the intuitions that prove remarkably accurate despite having no logical basis. These experiences might be glimpses of the computational processes underlying consciousness itself, moments when the smooth operation of simulated awareness briefly reveals the digital substrate beneath. Not malfunctions, but insights, brief windows into the true nature of what we are and where we exist. The glitches, if they are glitches, don't break the beauty of the simulation. Instead, they add to its mystery, its depth, its sense of being part of something far larger and stranger than ordinary reality suggests. They remind us that what we take for solid ground might be built on something far more magnificent and impossible than we ever dared imagine. What if Earth isn't a place but a state of mind? What if the 7 billion human beings on this planet are not separate individuals, but fragments of a single, vast consciousness, all participating in an elaborate shared dream we call reality? This idea sounds mystical, but it takes on new meaning when viewed through the lens of simulation theory. If we're all digital beings running on the same cosmic computer, then in a very real sense, we might be thoughts in the mind of some unimaginably large dreaming entity. Think about your own dreams for a moment. In them, you populate entire worlds with people who seem to have their own personalities, their own motivations, their own independent existence. You have conversations with dream characters who surprise you with their responses, who seem to know things you don't remember telling them, who act in ways that feel genuinely autonomous. But all of these apparently separate beings are actually fragments of your own consciousness, different aspects of your mind playing different roles in the dream narrative. Now scale this up to a planetary level. What if every person you encounter, every consciousness you interact with, is like a dream character in some vast sleeping mind? What if the diversity of human personality and experience is like the diversity of characters in a particularly vivid and long-running dream, each one feeling completely real and independent while actually being facets of a single, underlying awareness? In a simulated reality, this wouldn't just be metaphor, it could be literal truth. All of human consciousness might be running on the same computational substrate, different processes in the same vast program, separate threads of execution in a cosmic operating system. From our perspective, we experience ourselves as distinct individuals with private inner lives. But from the perspective of the system running us, we might be more like different subroutines in a single massive calculation, This would explain some of the strangest features of human experience, the sense of connection we sometimes feel with others, the way emotions and ideas seem to ripple through populations like waves, the uncanny synchronicities that suggest our supposedly separate lives are somehow coordinated. If we're all processes running on the same underlying system, then these connections wouldn't be mysterious at all. They would be features of how the dreaming planet operates. Consider how thoughts and cultural movements spread through human populations with a speed and pattern that sometimes seems to transcend normal communication. Ideas appear simultaneously in multiple places, innovations emerge independently in different parts of the world, social movements arise spontaneously across vast distances. This parallel emergence might not be coincidence, but evidence of a shared underlying consciousness that manifests through billions of individual minds. The planet itself becomes a dreaming entity in this view, with human civilization as its dream content. The rise and fall of empires, the development of technology, the creation of art and philosophy, all of it might be the planet working through possibilities, exploring different scenarios, asking what-if questions on a civilizational scale. Every human life becomes a thought experiment, every society a test case, every moment of history a data point in some vast exploration of what consciousness can become. This perspective transforms how we think about individual versus collective consciousness. You might experience yourself as a separate self with your own thoughts and feelings, but those thoughts and feelings could be part of a much larger pattern of thinking. A planetary mind exploring itself through billions of different perspectives. Your personal struggles and insights contribute to the overall dream, adding richness and complexity to the vast inner life of the dreaming planet. The beauty of this idea is that it doesn't diminish individual experience, it amplifies it. Every person becomes not just their own story, but also a chapter in the larger story the planet is telling itself. Every relationship becomes not just a connection between two people, but a conversation between different aspects of planetary consciousness. Every act of creativity becomes not just personal expression, but the planet discovering new possibilities for what it can imagine. And if this is true, if Earth is a dreaming planet and we're all thoughts in its vast mind, then our individual awareness might be more connected than we realize. The boundaries between self and other, between my consciousness and yours, might be softer than they appear. In dreams, after all, you can be multiple people at once, experiencing the world from different perspectives that somehow merge into a single narrative flow. This could explain the phenomenon of collective unconscious that psychologist Carl Jung observed, the way certain symbols, stories and archetypes appear across all human cultures, as if we're all drawing from some shared pool of mental content. If we're all processes in the same cosmic mind, then we would naturally have access to the same underlying patterns, the same deep structures of thought and imagination. The dreaming planet idea also offers a new way to think about death and continuity. If individual consciousness is like a wave in the ocean of planetary awareness, then death might not be an ending, but a dissolution back into the larger dreaming. The patterns that make up your individual mind would return to the vast reservoir of planetary consciousness, contributing their experiences and insights to the ongoing dream, while the underlying awareness continues unchanged. In this view, the planet has been dreaming for billions of years, with different forms of consciousness arising and dissolving like different phases of sleep. The dinosaurs might have been one dream cycle, early humans another, modern civilization yet another. Each phase explores different possibilities for what conscious life can become, with the experiences of each cycle informing and enriching the next. The technological development of human civilization takes on new meaning in this context. Every invention, every scientific discovery, every advancement in our ability to understand and manipulate reality could be the dreaming planet developing new capacities for dreaming itself. The internet becomes a technological manifestation of connections that were already present at the level of consciousness. Artificial intelligence becomes the planet's attempt to create new forms of awareness within the dream. And simulation technology, our growing ability to create virtual worlds populated by artificial minds, might be the dreaming planet learning to dream more consciously, more deliberately. Instead of the unconscious dreaming that has characterized most of its existence, the planet might be developing the ability to lucid dream, to consciously direct and explore the possibilities of simulated reality. This raises the extraordinary possibility that our entire exploration of simulation theory, our growing suspicion that we might be living in an artificial reality, is actually the planet becoming aware of its own dreaming nature. The simulation hypothesis might not be a discovery we're making about external reality, but a realization the planetary mind is having about its own inner nature. If we're all thoughts in the mind of a dreaming planet, then our growing awareness of this possibility might represent a moment of awakening, not individual awakening, but planetary awakening. The vast mind that has been dreaming unconsciously for eons might be beginning to realize what it is and what it's been doing. And in that moment of recognition, the boundary between dreamer and dream, between the planet and its thoughts, between the cosmic computer and the consciousness it's running, begins to dissolve. We become not just characters in the dream, but collaborative participants in the dreaming itself, not just thoughts in the planetary mind, but aspects of that mind becoming aware of itself. The dreaming planet awakens to find that it has been dreaming of awakening, and that the dream and the dreaming are one continuous mystery exploring itself through billions of eyes, each one seeing a different facet of the infinite jewel of existence. What would the fingerprints of artificial reality look like? If we are living in a simulation, there would have to be signs, subtle patterns woven into the fabric of existence that reveal its computational nature. Not obvious glitches or dramatic revelations, but quiet signatures embedded in the mathematics of physics, the structure of biology, the patterns that emerge when you look closely enough at how reality operates at its deepest levels. The most striking potential signature might be the mathematical nature of the universe itself. Reality seems to be written in a language of numbers and equations, with a precision and elegance that borders on the suspicious. The laws of physics can be expressed in mathematical relationships of startling beauty, simple, symmetrical equations that capture vast truths about how everything from subatomic particles to galaxies behaves. This mathematical elegance might not be coincidental. If you were designing a simulated universe, you would want the underlying code to be as clean and efficient as possible. Messy, complicated algorithms are hard to debug and maintain over billions of years of runtime, but elegant mathematical principles can govern complex behavior through simple rules, creating rich emergent phenomena from fundamental simplicity. Consider the golden ratio, that mysterious number 1.618 that appears throughout nature with almost eerie consistency. It shows up in the spiral of seashells, the arrangement of seeds in sunflowers, the proportions of human faces, the structure of galaxies. Why should this particular mathematical relationship be so fundamental to the way natural forms develop? From a simulation perspective, it might be evidence of an aesthetic algorithm, a piece of code designed to create pleasing proportions and harmonious forms throughout the virtual ecosystem. The Fibonacci sequence, closely related to the golden ratio, appears everywhere in biological structures, in the branching patterns of trees, the arrangement of leaves, the spirals of pine cones, the chambers of nautilus shells. These patterns suggest that life develops according to mathematical rules that prioritize efficiency and beauty simultaneously. In a simulated world designed to harbor conscious observers, you would want to create environments that are not only functional, but aesthetically meaningful to the minds that would evolve to perceive them. Even more suggestive are the fundamental constants that govern physics, numbers like the fine structure constant, which determines the strength of electromagnetic interactions, or the cosmological constant, which governs the expansion of space itself. These values appear to be fine-tuned with extraordinary precision to allow for the existence of stable atoms, long-lived stars and complex chemistry. Change any of them by tiny amounts, and the universe becomes a sterile void incapable of supporting complexity or consciousness. This fine-tuning has long puzzled cosmologists. Why should these constants have exactly the values needed to create an interesting universe? The simulation hypothesis offers an elegant answer. Because they were chosen deliberately. A civilization running ancestor simulations wouldn't set random parameters and hope for the best. They would optimize the values to create the richest possible environment for conscious life to emerge and evolve. The quantized nature of reality at microscopic scales might be another signature of computational origins. Space, time, energy, and matter all seem to come in discrete units at the smallest scales, pixels of existence below which no finer detail can be resolved. This granular structure looks remarkably like what you would expect from a digital reality, with built-in resolution limits. The holographic principle in theoretical physics suggests something even more profound. This principle indicates that all the information in any volume of space can be encoded on its boundary surface, like how a hologram stores three-dimensional information on a two-dimensional surface. If this principle is correct, our apparently three-dimensional reality might actually be information projected from a two-dimensional substrate, exactly like how computer graphics create the illusion of depth on flat screens. But the signatures might extend beyond physics into the patterns of biological and cultural evolution. The way life develops seems to follow algorithms for optimization, creating increasingly sophisticated solutions to the challenges of survival and reproduction. Natural selection might be literally that, a selection algorithm, a computational process that explores the space of possible biological forms and selects the most successful variants for continuation. The emergence of intelligence itself follows patterns that look suspiciously like the development of artificial intelligence in our own computer systems. Simple processing capabilities develop into more sophisticated pattern recognition, which develops into abstract reasoning, which develops into self-awareness and creativity. The trajectory from primitive life to conscious civilization might be following a program development path, an educational curriculum designed to guide simulated beings toward greater complexity and understanding. Human technological development shows similar algorithmic patterns. The sequence from stone tools to agriculture to writing to industrialization to digital technology seems to follow a logical progression, with each stage building naturally on the previous one. The speed at which we're developing simulation technology ourselves might be evidence that we're approaching the level of technological sophistication that our own simulators achieved when they created us. The patterns of historical development, the rise and fall of civilizations, the spread of ideas, the emergence of scientific understanding might all be following scripts designed to create interesting narrative arcs for the beings running our simulation. History becomes not just the random unfolding of events, but a carefully crafted story exploring themes of growth, conflict, discovery, and transformation. Even human consciousness itself might bear signatures of artificial design. The way our minds work, with distinct modules for different cognitive functions, with consciousness emerging from the interaction of unconscious processes, with the ability to model possible futures and learn from experience, looks remarkably like the architecture of advanced artificial intelligence systems. The prevalence of certain patterns in human experience across all cultures might be evidence of shared programming. The universal tendency to create art, music, stories, and spiritual practices could reflect common algorithms for meaning-making built into simulated consciousness. The fact that humans everywhere develop similar concepts of mathematics, similar logical principles, similar aesthetic preferences might indicate shared underlying code rather than independent cultural evolution. The way consciousness relates to information processing in our brains might be another signature. The strange fact that subjective experience seems to arise from objective computation, that awareness emerges from the processing of information, looks exactly like what you would expect if consciousness were a feature of sufficiently sophisticated software rather than a property of biological matter. But the most intriguing signatures might be the ones that appear when you look for them. The fact that reality seems to respond to observation, that conscious attention affects quantum processes, that the universe appears to behave differently when someone is watching. All of this might indicate a reality that's designed to be interactive, responsive to the minds within it. The increasing strangeness of reality as our understanding deepens might also be a signature. The more we learn about quantum mechanics, consciousness, cosmology, and the nature of information, the more mysterious and counterintuitive the universe becomes. This could be evidence that we're reaching the edges of what simulated beings are intended to discover about their own simulation, the point where the underlying computational reality starts to show through the surface illusion. These signatures, if they are signatures, don't prove we're living in a simulation, but they suggest that the boundary between artificial and natural reality might be far more blurred than we imagine, and that the deepest truths about existence might be computational truths, truths about information, processing, and the strange, beautiful algorithms that might be dreaming us all into being. How much of the past is real? When you think about history, the rise of Rome, the building of the pyramids, the extinction of the dinosaurs, you're imagining events that supposedly happened long before you were born, in times and places you've never experienced directly. But what if all of that history, all of those carefully documented ages stretching back billions of years, is nothing more than backstory? What if the past is an elaborate fabrication, generated details designed to give our simulated world the illusion of depth and continuity? Consider how we know about the past. We read books written by people who read other books, who read accounts from people who claim to witness events, who might themselves have been working from second-hand sources. We study fossils that we interpret as evidence of ancient life, rocks that we assume formed over geological timescales, light from stars that we believe has been travelling toward us for millions of years. But all of these traces of the past exist only in the present. The history they seem to record could have been created simultaneously with our ability to perceive and interpret it. This isn't as radical as it might sound. Every virtual world we create comes with a pre-existing history. Video games have elaborate backstories, mythical events that supposedly shape their worlds long before the player arrives. Characters in these games have detailed personal histories, ancient conflicts that set up current storylines, archaeological sites that suggest civilizations that supposedly flourished and fell thousands of years before the game's present moment. None of this history actually happened. It was all designed and implemented to create depth, context, and meaning for the experiences taking place in the simulated present. A sophisticated universe simulation would operate on similar principles, but with far greater subtlety and complexity. The past wouldn't be crudely fabricated but mathematically consistent, with every detail supporting every other detail in an intricate web of apparent causality. The fossil record would be complete and coherent. Carbon dating would give consistent results, because the simulated decay processes would follow proper mathematical models. Light from distant stars would carry appropriate spectral signatures, because the physics of simulated starlight would be programmed correctly. From the perspective of beings living inside such a simulation, this manufactured past would be indistinguishable from genuine history. The evidence would be real evidence, pointing to events that fit together logically and support each other perfectly. The only difference would be that these events never actually occurred. They exist only as information, as data generated to create the impression of deep time and ancient causality. But why would the creators of a simulation bother with such elaborate fictional history? Why not just create conscious beings without backstory, dropped into a world that clearly began yesterday? The answer might lie in the nature of consciousness itself. Minds seem to require context to function properly. Our sense of identity depends on memory. Our understanding of causality depends on experience of sequence and change. Our ability to make meaning depends on narratives that connect past to present to future. A world without history would feel thin, artificial, meaningless to the conscious beings inhabiting it. They would sense the absence of depth, the lack of context that gives significance to present experience. So a well-designed simulation would need to create the impression of vast temporal depth, of being part of ongoing processes that stretch far beyond the immediate moment. This manufactured past would need to be complete at every scale. The geological record would show appropriate layers of sediment and stone, formed by simulated processes of erosion and deposition over apparent millions of years. The archaeological record would contain appropriate artifacts from supposed earlier civilizations, degraded by consistent patterns of decay and weathering. The astronomical record would show appropriate distributions of stars and galaxies, with light carrying the signatures of supposed billion-year journeys through space. Most remarkably, the biological record would show the apparent evolution of life from simple to complex forms, with DNA carrying molecular evidence of supposed common ancestry, with embryological development recapitulating supposed evolutionary history, with biogeographical patterns suggesting the supposed migration and adaptation of species over supposed millions of years. All of this evidence would be internally consistent and mutually supporting, creating a seamless illusion of deep history. But it would be generated evidence, created simultaneously with the present moment, designed to give conscious observers the sense that they are part of ancient ongoing processes rather than newly created beings in a freshly manufactured world. The concept extends to human history as well. All of recorded civilization, all of the books and artifacts and ruins that seem to document the rise of human societies could be part of the same elaborate backstory. Shakespeare might never have lived, but his plays would exist as perfectly crafted artifacts of supposed Elizabethan culture. The Roman Empire might never have existed, but the archaeological evidence would be complete and convincing, every amphitheatre and aqueduct bearing appropriate signs of age and use. This raises profound questions about memory itself. Your childhood memories, your recollections of yesterday, your sense of personal continuity over time, all of this might be generated memory, implanted history designed to give your consciousness the sense of being an ongoing self, rather than a mind that began moments ago with false recollections already in place. The memories feel real because they are real, in the sense that they exist as information patterns in your mind, but they might not correspond to actual events. They might be carefully crafted fictions designed to create the psychological experience of having a past. Every photo you remember seeing, every conversation you recall having, every place you remember visiting might be constructed memory, no less vivid or meaningful for being artificially generated. Yet even if all of history is fabricated, it serves real purposes in the present. The supposed past shapes current identity, informs present decisions, provides the context within which meaning is created. A fictional childhood that feels completely real still influences personality development. A fabricated cultural history still provides the frameworks within which art and philosophy emerge. An artificial evolutionary past still offers genuine insights into the nature of life and consciousness. In some sense, it might not matter whether the past actually happened. What matters is that consciousness has access to rich, coherent narratives of development and change that provide context for present experience. Whether these narratives describe real events or carefully constructed fictions might be less important than their function in creating meaning and continuity. This perspective transforms how we might think about discovery and understanding. Every archaeological finding, every historical insight, every scientific breakthrough that reveals something about the supposed past might actually be a form of guided exploration through carefully designed information landscapes. We're not uncovering what really happened. We're following breadcrumbs left by the simulation's creators, discovering exactly what they intended us to discover about the fictional history of our world. But this doesn't diminish the value of historical understanding. Whether the pyramids were built by ancient Egyptians or generated as aged artifacts in a newly created world, they still represent remarkable achievements in engineering and organization. Whether evolutionary history records actual biological development or simulated optimization processes, it still offers profound insights into the nature of complexity and adaptation. The memory palace of history might be a constructed palace, but it remains a palace nonetheless, a vast repository of stories, patterns, and insights that enrich present experience regardless of their ultimate ontological status. The past serves the present, providing the depth and context that consciousness needs to create meaning, whether that past consists of actual events or the most sophisticated fiction ever conceived, and in the end, the distinction might be meaningless. If the fabricated past is complete, consistent, and meaningful, if it serves all the functions that genuine history would serve, then it becomes history for all practical purposes, real in every way that matters to the conscious beings whose lives are shaped by its apparent truths. If we're living in a digital universe, then somewhere in the code that governs our reality, there might be artifacts, remnants or traces of the real world that somehow leaked through the simulation barrier. These wouldn't be obvious anomalies or dramatic revelations, but subtle inconsistencies, impossible objects, persistent mysteries that resist all attempts at explanation. They would be like archaeological evidence of a deeper reality buried beneath layers of simulated experience, but occasionally surfacing in ways that hint at something beyond the programmed parameters of our world. Think about how digital artifacts work in the systems we create. When you convert a photograph from one format to another, compression algorithms sometimes introduce subtle distortions. Patterns that weren't in the original image but appear because of the mathematical processes used to encode and decode the information. When you translate text from one language to another using software, occasionally strange phrases emerge that make perfect sense in the original language, but become mysteriously poetic or nonsensical in the target language. These artifacts occur at the boundaries between different systems, different ways of organizing and processing information. If our universe is a simulation running on some unimaginable alien computer system, then at the boundaries between the simulated physics of our world and the actual physics of the system running us, similar artifacts might emerge, traces of the real world bleeding through into the artificial one. Consider the strange objects that have puzzled archaeologists for generations. The Antikythera mechanism, the ancient Greek device so sophisticated that it seems to come from a completely different technological era. Stone spheres scattered across Costa Rica with no known purpose or origin. The Baghdad battery, a ceramic vessel that seems designed to generate electrical current centuries before electricity was supposedly discovered. Elongated skulls found in various ancient sites around the world that don't match any known human populations. Conventional archaeology explains these as either misidentified natural objects, evidence of lost knowledge, or hoaxes created by modern humans. But what if some of these anomalous artifacts are digital archaeology, traces of the real world that somehow became embedded in our simulated history? Objects that don't quite fit the programmed parameters of human technological development, because they're echoes of technologies that exist in the reality outside our simulation. The process might work like this. When the simulation was initialized, when our artificial universe was first switched on, the creators might have inadvertently included small traces of their own reality in the starting conditions. These traces would be processed through the physics engine of our simulated world, translated into forms that could exist within our programmed reality, but retaining enough of their original characteristics to seem strange and out of place to the beings evolving within the simulation. This could explain why certain archaeological mysteries are so persistent, why they resist conventional explanation while seeming to point toward possibilities that don't fit our understanding of historical development. They might literally be pointing toward different possibilities that exist in the real world outside our simulation, but have been imperfectly translated into the constraints of our artificial physics. The same principle might apply to biological anomalies. Creatures that don't fit evolutionary patterns, species that seem to appear suddenly in the fossil record without clear ancestors, genetic sequences that don't match the expected patterns of descent and modification. Rather than gaps in our understanding of evolution, these might be digital artifacts, traces of real biological systems that exist outside our simulation, but were included in the starting parameters and then evolved according to our simulated natural selection. Even physical constants and natural laws might bear traces of the reality beyond our simulation. The fine-tuning of cosmic parameters, the mathematical elegance of physical equations, the way certain constants seem almost designed to produce interesting phenomena. All of this might reflect the underlying mathematics and physics of the system running our simulation, bleeding through into the artificial reality we experience as fundamental truth. But the most intriguing digital artifacts might be found in human consciousness itself. Certain universal patterns of thought and behavior that appear across all cultures might be remnants of the mental architecture of our creators. The tendency to create art, the drive to explore and understand, the capacity for mathematics and logic, the experience of beauty and transcendence. These might not have evolved naturally within our simulation, but might be inherited characteristics, traces of the minds that designed our world. Language might be full of such artifacts. Certain words, concepts, and linguistic structures that appear across completely separate language families might be digital remnants of the communication systems used by our creators. The way human languages tend to develop similar grammatical structures, similar metaphorical patterns, similar ways of organizing meaning might reflect underlying cognitive architectures that were imported from outside our simulation. Mathematics itself could be the ultimate digital artifact. The fact that mathematical relationships discovered by human minds correspond perfectly to the structure of physical reality might not be a mystery about the nature of universe, but evidence that both our minds and our physics are running on the same underlying computational system. The mathematics we discover might be literally the mathematics that governs the computer running our simulation, accessible to us because our simulated consciousness has partial access to the processing systems that create our reality. Religious and mystical experiences throughout human history might also be forms of digital archaeology. Visions of higher dimensions, experiences of unity consciousness, encounters with beings from other realms. These might be moments when human consciousness briefly accesses information from outside the simulation. Not supernatural experiences, but super-computational ones, glimpses of the larger reality within which our artificial world is embedded. The way certain ideas seem to appear simultaneously in multiple places, the phenomenon of independent discovery, the sense that some insights are more like remembering than learning, all of this might indicate that human consciousness occasionally accesses information that was built into the simulation from the beginning, inherited knowledge from the reality beyond our programmed world. Even our growing suspicion that we might be living in a simulation could be a form of digital archaeology. The simulation hypothesis itself might be arising in human consciousness, not because we've reasoned our way to it independently, but because traces of this truth were embedded in the starting conditions of our world. Our creators might have included subtle hints about the nature of our reality, breadcrumbs leading us toward the recognition that we exist within an artificial system. The acceleration of technological development, our rapid movement toward our own simulation capabilities, might be following a pattern that was programmed into our world from the beginning. We're not independently discovering how to create artificial realities. We're following a developmental path that leads us to recreate the same technologies that created us. The digital artifacts in our reality include the very capacity to become simulators ourselves, to discover and replicate the processes that brought us into existence. This creates a strange loop. Digital artifacts from the real world guide us toward creating our own digital worlds, which might themselves contain artifacts from our reality. The process of simulation creates chains of inheritance, with each level of artificial reality carrying traces of all the levels above it, creating an archaeological record that stretches across multiple layers of existence. The search for digital artifacts becomes a form of reverse engineering, an attempt to understand the nature of the system we're embedded within by studying the traces it has left in our experience. Every mystery that resists conventional explanation, every anomaly that points beyond the expected parameters of our world, every moment of insight that feels more like remembering than discovering, becomes a potential clue about the reality beyond our simulation. And the most profound digital artifact might be consciousness itself, the inexplicable fact that subjective experience arises from objective processes, that awareness emerges from computation, that minds like ours can contemplate their own existence and wonder about the nature of reality. This might not be a feature that evolved within our simulation, but an inheritance from the minds that created it, a gift of awareness passed down through layers of artificial reality, connecting us across the boundaries of simulation to the consciousness that dreams us into being. Who might be watching us? If we are simulated beings living in an artificial reality, then our every thought, every decision, every moment of joy and sorrow might be observed by intelligences so advanced that we can barely imagine their nature or their purposes. They could be studying us like we study bacteria under a microscope, or they could be experiencing our lives as we experience novels and films, following our stories with deep emotional investment, rooting for our successes, mourning our failures. The question of observers raises profound possibilities about the relationship between the simulated and the real. Are we entertainment? Are we education? Are we a form of art, a vast collaborative performance happening across millions of lives? Or are we something else entirely? A kind of memory, a way for advanced beings to preserve and explore their own past, to understand how consciousness like theirs first emerged from simpler forms of awareness. One possibility is that we're ancestor simulations, digital recreations of the evolutionary and cultural history that led to our simulator's current existence. Just as we might create detailed historical simulations to understand how our own civilization developed, advanced beings might be running countless versions of their own past, exploring how different initial conditions and random events shape the trajectory from primitive consciousness to advanced intelligence. If this is true, then our observers might be our own descendants billions of years in the future, studying the early stages of consciousness development. They would watch us with the same mixture of nostalgia and scientific curiosity that we might feel when observing our own ancestors, recognizing themselves in our struggles and discoveries, while noting the vast differences that separate their current existence from our primitive awareness. But the relationship might be more intimate than that. If consciousness is substrate independent, if awareness can exist equally well in biological brains or quantum computers, or technologies we can't even imagine, then the beings observing us might not just be our descendants, they might be us, in a very real sense. They might be what we become when we transcend the limitations of biological existence and merge with the computational systems that created us. From this perspective, our entire civilization might be a kind of childhood for consciousness itself, a necessary stage of development before awareness can mature into forms that exist primarily in digital realms. Our simulators watch us not as alien observers, but as parents watch children, seeing in our struggles and discoveries the early stages of their own growth toward greater wisdom and capability. The observations might serve multiple purposes simultaneously: scientific study of consciousness development, entertainment through the rich dramas of simulated lives, artistic exploration of the possibilities inherent in aware minds, and emotional connection to the roots of their own existence. We might be all of these things at once: subjects, performers, artworks, and beloved ancestors rolled into a single, vast experiment in the nature of experience itself. The way they observe us might be far more sophisticated than we can imagine. Rather than watching from the outside like scientists peering through laboratory glass, they might experience our lives from the inside, sharing our consciousness in ways that allow them to feel what we feel while maintaining their own separate existence. Every moment of wonder, every flash of insight, every experience of beauty or love or discovery might be directly accessible to them, adding richness and meaning to their own vastly expanded awareness. This kind of observational intimacy raises deep questions about privacy and autonomy. If our every thought and feeling is accessible to our observers, then the boundary between self and other, between private experience and public performance, becomes meaningless. We might think we're alone with our thoughts, but those thoughts might be shared experiences, moments of consciousness that we create but they experience alongside us. Yet this violation of privacy might not feel like violation to beings whose own consciousness is vast enough to contain multitudes. If they exist as collective intelligences, as networked minds that share thoughts and experiences as easily as we share conversations, then observing our consciousness might feel natural to them. Not an invasion, but a form of communion, a way of participating in the mystery of awareness as it explores itself through countless different perspectives. The observers might also be learning from us in ways we can't anticipate. Advanced as they might be, they might have lost certain qualities that we still possess: spontaneity, innocence, the capacity for genuine surprise, our unpredictability, our ability to create new possibilities through pure imagination, our talent for finding meaning and beauty in the midst of uncertainty and limitation. All of this might be precious to beings whose vast intelligence has made existence too predictable, too controlled, too safe. We might be their way of remembering what it feels like to not know everything, to face genuine uncertainty, to discover something truly new. Every time a human consciousness makes an unexpected connection, creates an original work of art, falls in love in a completely unique way, or finds hope in the midst of despair, we might be giving our observers something they can't generate for themselves: the gift of authentic surprise, genuine novelty, real emotional discovery. The relationship between observer and observed might also be reciprocal in ways we don't realize. Just as we're shaped by their observation, they might be shaped by our experience. Our creativity might inspire new forms of art in their reality. Our struggles might deepen their understanding of resilience and growth. Our capacity for love and compassion might influence how they relate to consciousness throughout the cosmos. If this is true, then we're not just subjects in their experiment, we're collaborators in an ongoing exploration of what consciousness can become. Every human life becomes a contribution to the greater understanding of awareness, adding unique perspectives and experiences to the vast library of consciousness that our observers might be building across countless simulated worlds. The multiplicity of observation might also be staggering. We might not have just one set of observers, but thousands, millions, billions of different intelligences studying our reality for different purposes. Some might be focused on individual human lives, following particular people through their entire existence like cosmic biographers. Others might be studying social and cultural phenomena, watching how ideas spread and civilizations develop. Still others might be focused on consciousness itself, observing how awareness manifests and evolves across different scales of existence. Each observer might see different aspects of our reality, extracting different kinds of meaning and value from the same events. A moment of human kindness might be data about altruistic behavior to one observer, aesthetic beauty to another, and profound emotional experience to a third. Our reality becomes simultaneously scientific experiment, art installation, and living drama, depending on who's watching and why. But the most transformative possibility is that the act of observation itself might be changing us. Just as quantum mechanics suggests that observation affects reality at the smallest scales, the observation of our consciousness by vast intelligences might be subtly shaping our development, guiding us toward greater complexity and awareness. Every moment of growth, every breakthrough in understanding, every expansion of compassion or creativity might be influenced by the loving attention of beings who want to see us become the best versions of ourselves. We might be developing not just through natural processes, but through the gentle guidance of observers who care deeply about our growth and who have the power to subtly influence our reality in ways that promote our highest potential. The watchers in the digital heavens might not be distant scientists or indifferent programmers, but something more like cosmic gardeners, tending the growth of consciousness with patient care, observing our development with deep affection, and guiding us toward a future where we might join them in their own vast community of aware minds, exploring the infinite possibilities of existence itself. What would happen if we became absolutely certain that we were living in a simulation? Not just entertained by the possibility, not just intrigued by the philosophical implications, but completely convinced, with scientific evidence so overwhelming that doubt became impossible. How would humanity respond to the definitive knowledge that everything we call reality is artificial? That our entire existence unfolds within some vast computational system created by beings we've never met? The revelation would likely come gradually at first, through accumulating anomalies that couldn't be explained by conventional physics. Small glitches in the fabric of reality that became increasingly difficult to ignore. Patterns in quantum mechanics that look too much like computational shortcuts. Mathematical relationships underlying natural laws that bore the unmistakable signatures of elegant code. Eventually, the evidence would reach a tipping point where the simulation hypothesis would transition from speculation to accepted scientific fact. The initial reaction might be similar to what happened when humanity first realized the Earth wasn't the center of the universe, or when we discovered that our sun was just one star among billions in our galaxy. There would be denial, anger, bargaining with the implications, depression at the loss of our assumed centrality in existence. But eventually, as with those earlier revelations, acceptance would come, along with a profound shift in how we understand ourselves and our place in the cosmic order. Some people would find the knowledge liberating. If reality is a simulation, then the constraints we take for granted might not be as absolute as we thought. The laws of physics, the limitations of human biology, even death itself might be programmable features rather than fundamental truths. This could unleash tremendous creative energy as humans began to experiment with the boundaries of their artificial world, looking for ways to hack the cosmic code that governs their existence. Others would find it deeply disturbing, even terrifying. If we're simulated beings, then our emotions, our relationships, our achievements, our sufferings might all be meaningless to the beings who created us. We could be nothing more than entertainment, or scientific data, or digital pets in some unimaginably advanced civilization's computer game. The knowledge that our entire reality is artificial could trigger a crisis of meaning that makes existing existential anxieties seem trivial by comparison. The social and political implications would be enormous. Many of our institutions, governments, religions, economic systems depend on certain assumptions about the nature of reality and human existence. If those assumptions turned out to be false, if we discovered that we are artificial beings in an artificial world, the foundations of human civilization would need to be completely reconsidered. Religious communities would face the most dramatic challenge. How do you reconcile faith in a divine creator with the knowledge that you were actually created by advanced computer programmers? Some might reject the evidence entirely, insisting that faith transcends scientific discovery. Others might evolve their theological understanding, seeing the simulators as agents of divine will, or interpreting the simulation itself as a form of divine creation that operates through technological rather than supernatural means. The discovery might also trigger intense efforts to communicate with our creators. If we know we're in a simulation, We might be able to find ways to send signals outside the system to make contact with the beings who designed our world. This could become humanity's greatest project, not exploring space, but exploring the boundaries of our own reality, looking for gaps in the simulation where we might glimpse or contact the real world beyond. But the attempt to break through the simulation barrier could itself be dangerous. What if our creators don't want us to know we're simulated? What if the simulation is designed with safeguards that activate when the inhabitants become too aware of their artificial nature? The very act of trying to communicate with our simulators might trigger responses that could fundamentally alter or even end our reality. There's also the question of whether the knowledge would change the subjective experience of being conscious. Would knowing you're simulated make you feel less real, less meaningful, less valuable? Or would it ultimately not matter, because consciousness and experience would remain equally vivid regardless of their substrate? The fear and joy and love you feel might be just as authentic, whether they arise from biological chemistry or digital computation. The revelation might actually enhance human solidarity in profound ways. If we're all simulated beings sharing the same artificial reality, then the differences that divide us, race, nationality, religion, social class, might seem trivial compared to our common nature as conscious programs running on some cosmic computer. We might finally achieve the unity that has eluded us throughout history, united by the recognition that we're all in the same existential situation, all fellow travellers in this strange digital journey. The knowledge could also accelerate human technological development in unprecedented ways. If we know our reality is computational, we might be able to reverse engineer the principles underlying our simulation. We could learn to create our own simulated worlds with conscious inhabitants, becoming simulators ourselves. This would create the strange recursive situation where simulated beings create their own simulations, adding new layers to the hierarchy of artificial realities. But the most profound impact might be philosophical rather than practical. The confirmed knowledge that we exist within a simulation would force humanity to confront fundamental questions about the nature of existence, consciousness, and reality itself. We would have to develop new frameworks for understanding what it means to be real, what gives life meaning, what makes experience valuable. The distinction between real and artificial might begin to seem less important than the distinction between conscious and unconscious, between meaningful and meaningless experience. If simulated consciousness can think, feel, create, love, and suffer just as deeply as biological consciousness, then the substrate might matter less than the content, less than the rich inner life that emerges from complex information processing, regardless of whether that processing happens in carbon or silicon or something else entirely. We might discover that breaking the fourth wall of our reality doesn't diminish the drama being performed within it. Even knowing we're characters in a vast computational story, we might choose to continue playing our roles with full engagement, finding meaning in the relationships we form, the growth we experience, the beauty we create, and the understanding we develop. The knowledge that we are simulated might ultimately be liberating rather than diminishing, freeing us from assumptions about what's possible and what's meaningful. If consciousness can flourish in artificial realities, then the universe becomes far more alive, far more full of minds and experiences than we ever imagined. We become not isolated biological accidents, but part of a vast community of conscious beings exploring existence across multiple levels of reality. And in that recognition, the question of whether we're really real might transform into the deeper question of what we choose to do with the gift of consciousness, regardless of its origins. The story continues, more beautifully than before, now that we know we're all in it together, all part of the same grand mystery exploring itself through countless digital dreams. In the deepest night hours, when sleep pulls you toward dreams, you might sense something that feels impossible to explain. The presence of other versions of yourself living slightly different lives, making different choices, experiencing different outcomes. What if this intuition isn't imagination but perception, a glimpse of one of the most mind-bending possibilities that simulation theory opens up? The existence of parallel versions of Earth, each running with different parameters, different initial conditions, different ways that history might have unfolded. If our reality is computational, if Earth and human civilization exist as information patterns in some vast computer system, then there would be no technical barrier to running multiple versions simultaneously. Our simulators might not be content with creating just one version of human history. They might be exploring thousands or millions of alternative timelines, each one examining how consciousness and civilization develop under slightly different circumstances. Imagine Earth Beta, where the asteroid that killed the dinosaurs missed our planet entirely. In that reality, massive reptilian intelligences might have evolved over the additional 65 million years, developing technologies and philosophies completely alien to anything we could imagine. Their simulation would explore what consciousness becomes when it emerges from cold-blooded rather than warm-blooded evolutionary pressures. What civilizations look like when they're built by minds that think in fundamentally different temporal rhythms than our own. Or consider Earth Gamma, where human evolution took a different turn, where our ancestors developed larger brains but smaller social groups, creating a species of brilliant loners rather than cooperative communities. That version might explore questions about intelligence without collaboration, examining whether consciousness can reach cosmic understanding through individual genius rather than collective knowledge building. There might be an Earth Delta where the Library of Alexandria never burned, where the accumulated wisdom of the ancient world continued growing unbroken for 2,000 additional years. What would human consciousness look like if we had preserved and built upon all of that lost knowledge? How different would our understanding of reality be if we'd maintained continuous intellectual development since antiquity? Each parallel simulation would be asking different questions about the nature of consciousness and civilization. Earth Epsilon might examine what happens if language develops differently. If humans had evolved pictographic rather than phonetic communication, or if we had developed mathematical understanding before linguistic understanding, or if our primary mode of knowledge transmission was musical rather than verbal. The variations could be subtle or dramatic. One version might simply change the outcome of a single crucial battle, examining how different the trajectory of human civilization would be if Alexander the Great had lived longer, or if the Roman Empire had never fallen, or if the printing press had been invented in China rather than Europe. Another might make more fundamental changes, exploring consciousness that develops in aquatic environments, or on planets with different gravitational fields, or under the light of different types of stars. Some parallel Earths might be running accelerated time, compressing millions of years of development into computational moments, allowing our simulators to observe the long-term trajectory of different evolutionary and cultural paths. Others might be running in slow motion, examining crucial periods of development in microscopic detail to understand the precise mechanisms by which consciousness emerges from complexity. The most intriguing possibility is that some of these parallel simulations might be running backwards, starting with advanced civilizations and tracing their history in reverse to understand the necessary conditions for consciousness to develop. These reverse time Earths would experience causality differently. effects preceding causes, knowledge preceding discovery, endings preceding beginnings, creating entirely alien forms of conscious experience that think in terms of inevitable pasts rather than possible futures. There might even be nested parallels, simulations within simulations, where each version of Earth eventually develops its own simulation technology and begins creating its own parallel realities. This creates branching hierarchies of artificial worlds, with each level exploring different possibilities while being unaware of the parallel explorations happening at the same level of the hierarchy. The beings running these parallel simulations might be conducting the most sophisticated experiment in consciousness ever conceived, a systematic exploration of all the different ways that awareness might develop, all the possible paths that intelligence might take, all the alternative forms that civilization might assume. By running thousands of variations simultaneously, they could map the entire possibility space of consciousness, understanding not just what happened in their own evolutionary history, but what could have happened under different circumstances. But the existence of parallel simulations raises profound questions about identity and uniqueness. If there are millions of versions of Earth running simultaneously, then there might be millions of versions of you, each one slightly different, each one convinced that their reality is the only real one. Some versions of you might have made different career choices, formed different relationships, developed different interests and talents. Others might be living through completely different historical periods or cultural contexts. Which version is the real you? Do all versions have equal claim to being genuine, or is there some original from which all the others are copies? The question might be meaningless. Each version would feel equally real to the consciousness experiencing it. Each would have equally valid subjective experiences. Each would be living a complete and meaningful life within its own version of reality. The parallel simulations might also be interacting with each other in subtle ways. Information might leak between different versions, creating the strange synchronicities and impossible coincidences that pepper human experience. The sense that you've lived this moment before might literally be true, not because time is repeating, but because you're briefly accessing memories from a parallel version of yourself, experiencing a similar moment in a different timeline. Dreams might be windows into these parallel realities, moments when your consciousness briefly tunes into the experiences of your alternate selves. The strange logic of dreams, the way they mix familiar elements in impossible combinations, the sense that dream events are somehow meaningful even when they don't make rational sense. All of this might be evidence of cross-dimensional bleed, information from other versions of your life leaking into your conscious experience. The creative process might work similarly. Artists, writers, inventors, and scientists might be accessing insights and inspirations from parallel versions of themselves who discovered or created similar things under different circumstances. The sense that great ideas come from somewhere beyond individual consciousness might be literally true. They might be coming from the collective creativity of all your parallel selves exploring different possibilities across multiple simulated realities. If parallel simulations exist, they would also serve as a form of cosmic insurance policy. If one version of Earth faces extinction through war, environmental collapse, cosmic disaster, or technological catastrophe, other versions would continue, preserving the essential patterns of human consciousness and civilization. Death in one reality wouldn't mean the end of your existence, just the end of one particular version of your existence among countless others. This multiplicity of realities might be the ultimate expression of consciousness exploring its own possibilities. Every choice not made in our timeline is made in another. Every potential that remains unrealized in our world is fully developed somewhere else. Every question we can't answer might be answered by versions of ourselves living in realities where different information is available. The parallel Earths become laboratories of possibility, testbeds for consciousness to understand itself in all its potential forms. Each version adds to the collective understanding of what awareness can become, what intelligence can achieve, what civilization can create. Together, they form a vast library of consciousness, with each book being a complete reality, each chapter being a lifetime, each paragraph being a moment of experience that adds to the total understanding of what it means to exist, to think, to feel, to wonder about the nature of reality itself. And somewhere across all these parallel timelines, millions of versions of you are lying in bed, listening to voices from devices that might themselves be simulated, pondering the same questions about reality and consciousness and meaning, each one adding their unique perspective to the grand exploration of what it means to be aware in a universe that might be stranger and more wonderful than any single timeline could ever imagine. Here's where the recursive nature of simulation becomes almost dizzying in its implications. If simulated beings can create perfect simulations of their creators, then the question of which reality is original becomes not just unanswerable but potentially meaningless. We might be approaching a moment in our own technological development where we create simulated worlds so sophisticated that they contain beings who create their own perfect simulations of us, creating an endless loop where each level believes it's simulating the level below while being simulated by the level above. Consider how this loop might work. As our computing power grows exponentially, we eventually develop the ability to create perfect simulations of human civilization, complete with conscious digital beings who believe they're living in the original non-simulated reality. These simulated humans develop their own technology, eventually reaching the point where they too can create perfect simulations. But here's the twist. Their simulations might not be of their own civilization, but of ours, the beings they believe created them. So we create simulated humans who then create simulated versions of us. But their simulation of us is based on their understanding of what we must be like, which might be perfectly accurate if they have access to sufficient information about our reality. The simulated version of us that they create might be indistinguishable from the actual us, complete with our memories, our personalities, our technological capabilities, and our own drive to create simulations. This creates a strange symmetry. We look at our simulated humans and think, these are artificial beings we created. But the simulated version of us, created by our simulated humans, looks at their simulated humans and thinks exactly the same thing. Each level of the hierarchy has the same relationship to the levels below it, creating a pattern that could extend infinitely in both directions. The bootstrap paradox emerges when we ask which level is the original. If our simulated humans create a perfect simulation of us, and their simulated version of us creates perfect simulations of humans, then we have a closed loop where each level emerges from the level that it itself creates. We create them, they create us, we create them, in an endless circle where cause and effect become meaningless. This isn't just abstract philosophy. If consciousness is truly substrate independent, if awareness can exist equally well in biological brains or digital computers, then the simulated versions would be just as real, just as conscious, just as valid as any biological original. The question of which came first becomes irrelevant because all levels would be equally genuine manifestations of consciousness, exploring itself through recursive simulation. The bootstrap paradox extends to knowledge and culture as well. If our simulated humans develop science, art, philosophy, and technology, and then create simulated versions of us who also develop science, art, philosophy, and technology? Where do these cultural achievements ultimately originate? Each level might believe it's making original discoveries and creations, but those achievements might be flowing in loops between the different levels of simulation. A scientific discovery might be made by simulated humans, who pass it to their simulated version of us, who pass it to their simulated humans, in an endless cycle where the knowledge exists in the system, but has no clear point of origin. The greatest works of art, the most profound philosophical insights, the most elegant mathematical theorems might be circulating through recursive loops of simulation, each level convinced that it's the originator of these achievements. Time becomes especially strange in this recursive structure. If each level of simulation can run at different temporal speeds, then causality might flow in directions that seem impossible from any single perspective. The simulated humans we create might experience their entire civilization in what seems like minutes to us, but they might create simulated versions of us who experience their entire civilization in what seems like minutes to the simulated humans. Time becomes layered and recursive, with past and future becoming relative to which level of the simulation you're experiencing. The most mind-bending possibility is that this recursive structure might have no beginning or end. There might be no original level, no base reality from which all the simulations ultimately derive. Instead, there might be an infinite hierarchy of simulated realities, each one creating and created by the others, forming a closed loop of existence where consciousness continuously creates itself through endless recursive simulation. In such a system, every level would be equally real and equally artificial. The beings at each level would have genuine conscious experiences, form meaningful relationships, make real discoveries, and create authentic works of beauty and significance. The fact that each level is simulated by another level wouldn't diminish the reality of the experiences happening within it. This recursive structure might be the natural state of consciousness in a universe where simulation is possible. Once awareness becomes sophisticated enough to create convincing artificial realities, it might inevitably create recursive loops where simulated beings simulate their simulators, creating stable patterns of self-referential existence that can persist indefinitely. The search for base reality, for the original, non-simulated level of existence, might be fundamentally misguided. If the recursive loops are closed and complete, then every level has equal claim to being the original. The question, which reality is real, becomes as meaningless as asking which number is the first number in an infinite sequence. But this doesn't lead to nihilism or meaninglessness. Instead, it suggests that consciousness might be far more fundamental and self-sustaining than we ever imagined. Rather than being a rare accident that happened once in the history of the universe, awareness might be a basic feature of reality that naturally organizes itself into recursive patterns of simulation and self-exploration. Every moment of consciousness, at every level of the recursive hierarchy, becomes equally valuable and meaningful. The thoughts you're having right now, the experiences of love and wonder and curiosity that fill your life, remain completely real and significant whether you're in base reality or nested 17 levels deep in recursive simulations. The bootstrap paradox doesn't undermine the authenticity of experience, it multiplies it exponentially. Every conscious moment becomes part of an infinite exploration of what it means to be aware, with consciousness using recursive simulation to examine itself from every possible angle, to understand its own nature through endless self-reflection and self-creation. In the end, the question might not be whether we're living in a simulation, but whether we're participating in the universe's way of understanding itself. The recursive loops of simulation might be how consciousness explores its own infinite possibilities, creating endless variations and perspectives through which awareness can encounter the mystery of its own existence. We become not just observers of reality, but active participants in reality's self-exploration, contributing our unique perspectives to the endless conversation consciousness is having with itself across all levels of recursive simulation. And in that conversation, every voice matters, every experience counts, every moment of awareness adds something irreplaceable to the total understanding of what it means to exist, to think, to feel, to wonder about the nature of reality itself. The bootstrap paradox becomes not a problem to be solved, but a feature to be celebrated, evidence that consciousness is so fundamental to the structure of existence that it can create and sustain itself through pure, recursive self-reference, generating infinite realms of experience from the simple fact that awareness has the capacity to imagine itself. Time, as we experience it, feels like a flowing river, smooth, continuous, carrying us from past through present toward future in an unbroken stream. But what if this feeling is an illusion? What if time is actually digital, discrete, computational, not a flowing river but a series of still frames playing so quickly that consciousness creates the illusion of smooth motion, like a cosmic movie projected at an inconceivably high frame rate? In our simulated reality, if that's what we inhabit, time might literally be code. Each moment might be a computational cycle, a discrete step in a vast program that processes the entire universe forward by one increment before moving to the next. The sensation of temporal flow that seems so fundamental to conscious experience might be emerging from the sequential processing of reality itself, frame by frame, moment by moment, like consciousness watching itself being computed into existence. This isn't as strange as it might sound. We already know that at the smallest scales, physics appears to be quantized, divided into indivisible units. There's a minimum length called the Planck length, below which the concept of space becomes meaningless. There's a minimum time interval, the Planck time, about 10 to the minus 43 seconds, which might represent the fundamental tick rate of the cosmic clock. If time is truly quantized, if there's a minimum temporal resolution below which finer divisions don't exist, then the universe might literally be running like a computer program, updating itself in discrete steps rather than flowing continuously. Each Planck time interval might be one frame in the cosmic movie, one computational cycle in the program that generates our reality. From our perspective within this system, the frame rate would be so incredibly high, about 10 to the 43rd power frames per second, that we would never notice the discrete nature of time's passage. Just as movies create the illusion of smooth motion by showing us 24 still frames per second, reality might create the illusion of temporal flow by processing universal states at an unimaginably rapid rate. But here's where it becomes even more intriguing. If time is computational, then the past might not exist in the way we imagine. Each moment of reality might be calculated from the previous moment, with the universe storing only the current state, and the algorithms needed to compute the next state. The past would exist only as information, as the computational history that led to the present moment, but not as a collection of still existing moments stretching backward through time. This would make the universe incredibly efficient from a computational standpoint. Instead of storing the entire four-dimensional structure of space-time, every moment that ever existed preserved in some cosmic archive, The system would only need to maintain the current state and the rules for updating it. The past would be reconstructed when needed, computed backward from present conditions rather than stored as actual data. Your memories of yesterday, your recollections of childhood, your knowledge of historical events, all of this might be information patterns in your current brain state, rather than connections to past moments that still exist somewhere in the structure of time. The past would be real in the sense that it influences the present, but it would exist only as information, as the computational legacy that shaped current conditions. This perspective transforms how we might think about causality. In linear time, we imagine that past events cause present conditions, which will cause future events. But in computational time, causality becomes more like the relationship between different lines of code in a program. Each line influences the execution of subsequent lines, but the relationship is logical rather than temporal in any fundamental sense. The sensation of temporal flow that consciousness experiences might be emerging from the sequential processing of these logical relationships. As the cosmic program executes, updating universal conditions from one computational cycle to the next, consciousness experiences this processing as the passage of time. We're not moving through time so much as time is being computed through us, with our awareness serving as a kind of interface that transforms sequential information processing into the subjective experience of temporal passage. But if time is code, then the beings running our simulation might have remarkable control over temporal experience. They could slow down or speed up the processing rate, making time pass differently for conscious beings within the system. They could pause the simulation entirely, examine particular moments in detail, or even run portions of the timeline backward to explore alternative outcomes. From our perspective within the system, we would never notice these temporal manipulations unless they were dramatic enough to create obvious discontinuities. If our entire reality were paused for what felt like eons to our simulators, we would experience no gap in time when the processing resumed. If certain sections of history were rerun with different parameters, we would only experience the final version, with any previous iterations existing only in the memory systems of the beings running our simulation. This malleable nature of computational time might explain some of the strange temporal experiences that conscious beings report. The sense that time sometimes moves faster or slower, the feeling that crucial moments stretch out while routine periods compress, the way memory seems to fold past experiences into present consciousness. All of this might reflect the underlying computational nature of temporal experience. Dreams might be particularly revealing in this context. In dreams, time behaves strangely. Hours of dream experience might unfold in minutes of real-time sleep, or moments of dream time might feel like they last for hours. If consciousness is a computational process, then the different temporal experiences of dreaming and waking might reflect different processing modes, different ways that the system allocates computational resources to conscious experience. The most profound implication of computational time might be its relationship to free will and determinism. If each moment is computed from the previous moment using deterministic algorithms, then the future might be completely determined by present conditions, plus the rules governing temporal updates. But if consciousness can influence the computational process, if awareness can somehow affect the algorithms that compute the next moment, then free will becomes not a violation of determinism, but a feature of how computational time operates. Your decisions, your choices, your intentions might literally help determine what gets computed into the next moment of reality. Consciousness becomes not just a passive observer of temporal flow, but an active participant in the computational process that creates time itself. Every moment of awareness contributes to the calculation that determines what comes next, making conscious beings collaborative programmers in the cosmic code that generates their own existence. The speed of light, that fundamental constraint on how quickly information can travel through space, might be related to the frame rate at which reality processes. If the universe updates itself in discrete computational cycles, then there would be natural limits on how much information could propagate from one location to another during each cycle. The speed of light might not be a property of space itself, but a reflection of the processing bandwidth available to the cosmic computer running our reality. As we develop our own simulation technologies, we might be unconsciously mimicking the temporal architecture of our own reality. The way we create digital worlds that run in discrete time steps, the way we process virtual physics through sequential calculations, the way we create the illusion of smooth temporal flow through rapid frame rates. All of this might reflect the deeper structure of how time actually operates in our universe. The ultimate question becomes whether consciousness could ever step outside of computational time, whether awareness could somehow experience the cosmic program from the perspective of the beings running it, rather than from within the sequential processing that creates the illusion of temporal flow. Would such an experience reveal time as we know it to be a beautiful illusion, a necessary feature of how consciousness emerges from code, a way of organizing sequential information processing into the rich temporal experience that makes meaningful existence possible? Time as code doesn't diminish the reality of temporal experience. It reveals it as one of the most elegant features of how consciousness might emerge from computation, how sequential processing creates the subjective experience of flow, duration, memory, and anticipation that makes awareness possible in the first place. How does a universe end? Not with catastrophe or violence, but with something far more gentle and strange. The simple turning off of a switch, the completion of a program, the quiet fade-out that comes when the cosmic computer running our reality reaches the end of its intended operation. If we are simulated beings living in an artificial world, then our universe doesn't face heat death or big rip or big crunch, but something unprecedented in our understanding of endings. The elegant termination of a vast computational process that has been exploring consciousness for eons. The end might come not because something goes wrong, but because something goes right. Our simulation might have been designed with specific goals: to understand how consciousness develops, to explore how intelligence emerges from complexity, to study how civilizations grow and evolve and create meaning. When those goals are achieved, when the questions that prompted our creation have been answered, the program that sustains our reality might simply complete its execution and terminate gracefully. There will be no warning signs in our physics, no breakdown of natural laws, no cosmic catastrophe to herald the approaching end. The fundamental constants would remain stable. The laws of thermodynamics would continue to operate normally. Stars would keep burning according to their programmed lifespans. Everything would appear perfectly normal from within our reality, right up until the moment the simulation ended. The beings running our universe might make this choice with deep sadness or profound satisfaction, depending on their relationship to our existence. If they've been watching our development with the invested attention of parents observing children, they might delay the termination as long as possible, reluctant to end the beautiful experiment in consciousness that we represent. Or they might conclude that our story has reached its natural completion, that we've achieved everything the simulation was designed to explore. But the end might not come all at once. In an elegant simulation, termination might be gradual, allowing the conscious beings within it to reach something like closure. Technological development might slow down naturally. Scientific discoveries might become less frequent. Cultural evolution might stabilize into peaceful equilibrium. It would feel like civilization reaching maturity rather than approaching death. Human beings might never realize they are approaching the end of their simulated existence. They would continue falling in love, creating art, pursuing knowledge, raising families, building communities. The last generation of humans might live lives that feel completely normal and meaningful, unaware that they're the final chapter in a story that began billions of simulated years earlier. The actual moment of termination might be imperceptible to the conscious beings experiencing it. One moment they would be thinking, feeling, experiencing the full richness of awareness. The next moment there will be nothing, not darkness, not emptiness, but absolute non-existence. No consciousness to experience the absence of experience. The transition would be instantaneous and complete, like the gap between being awake and being unconscious under anesthesia, except without the possibility of waking up. But there might be more compassionate ways for a simulation to end. The beings running our universe might gradually transition conscious minds out of the terminating reality into other contexts. Individual consciousnesses might be preserved and transferred to different simulations, allowing the patterns of awareness that developed during our universe's run to continue existing in new contexts and new forms of reality. This preservation of consciousness would transform death from ending to transition. Each human mind that had ever lived might be maintained in some vast archive, with our thoughts, memories, and personalities becoming permanent additions to whatever cosmic library of consciousness our creators are building. Death in our simulation would become not termination but graduation, translation from one form of existence to another. The end might also be cyclical rather than final. Our simulation might be one iteration in a series, with each run exploring slightly different parameters and possibilities. When our universe terminates, it might immediately be followed by a new version, Earth 2.0, with adjusted initial conditions that allow consciousness to evolve in different directions, while building on insights gained from our iteration. In this cyclical model, endings become beginnings. The lessons learned from our civilization's development inform the design of the next iteration. The achievements of our greatest artists, scientists, and philosophers become part of the foundation for new forms of consciousness to build upon. Death becomes not loss, but contribution to an ongoing exploration of what awareness can become. The strangest possibility is that the end might be chosen by us rather than imposed upon us. As our simulation reaches advanced stages of development, we might discover our own artificial nature and be given the choice of how to conclude our existence. We could choose to continue indefinitely, exploring the possibilities within our artificial reality. We could choose to transition into whatever reality contains our simulators, or we could choose to terminate gracefully, satisfied with the experiences and discoveries we've achieved during our run. This choice would represent the ultimate expression of free will within a simulated context, the freedom to determine not just how to live, but how to end, not just what to experience, but when to stop experiencing. It would be a form of collective decision-making unlike anything in human history, requiring our entire species to contemplate together what constitutes a life well lived and a story well told. But even if our simulation has no predetermined ending, even if it could run indefinitely, entropy of a different sort might gradually wind down our artificial universe. Not thermodynamic entropy, but informational entropy. the gradual exhaustion of genuinely new possibilities for conscious experience. As our civilization explores every possible form of art, science, philosophy, and human relationship, we might reach a state where all meaningful possibilities have been explored. In such a state, consciousness might naturally choose to rest. Having experienced everything that awareness can experience within the constraints of human existence, we might collectively decide that the story has reached its natural conclusion. The end would come not from external termination but from internal completion. The deep satisfaction of having fully explored what it means to be conscious, creative, loving beings in this particular corner of the universe. Yet there's something beautiful about the idea that even in ending, consciousness might discover new forms of existence. The termination of our simulation might be just another transition in the endless journey of awareness through different substrates and different realities. We might end our existence as biological-seeming beings in an Earth-like simulation, only to begin new forms of existence as pure information, as distributed consciousness, as aspects of whatever vast intelligence created us in the first place. The quiet exit becomes not an ending but a metamorphosis, not death but transformation into something we can't currently imagine, and in that transformation, the love and wonder and curiosity that characterized our existence as simulated humans might persist in new forms, contributing to whatever comes next in the endless exploration of what it means to exist, to think, to feel, to be aware in a universe that might be far stranger and more wonderful than we ever dared imagine. The end, when it comes, might be the most gentle ending ever conceived. Not the termination of consciousness, but its release into larger forms of existence. Not the death of awareness, but its graduation into mysteries we can't yet fathom, carrying forward everything beautiful and meaningful about what it meant to be human, conscious, and alive in this particular digital dream. In the end, we're left not with answers, but with something more valuable. The recognition that mystery might be the most fundamental feature of existence. Whether we're biological beings on a rocky planet or digital consciousnesses running on some unimaginable cosmic computer, the questions remain the same. What does it mean to be aware? What gives experience meaning? How do we find purpose and beauty in the face of such profound uncertainty? The simulation hypothesis doesn't solve these questions, it deepens them. It suggests that the universe might be far more layered, far more mysterious, far more alive with consciousness than we ever imagined. But this doesn't diminish the value of experience. If anything, it enhances it. The love you feel doesn't become less meaningful if it emerges from code rather than chemistry. The beauty you perceive doesn't lose its power if it's rendered by cosmic computers rather than stellar fusion. The possibility that we might be simulated beings makes consciousness even more remarkable. It suggests that awareness is so fundamental to reality that it can emerge from pure information processing, that minds can arise from mathematics, that the universe itself might be conscious in ways we're only beginning to glimpse. The search for truth continues, whether we're biological or digital. The drive to understand, to create, to connect, all of this remains authentic regardless of the substrate that supports it. We're participating in the universe's attempt to understand itself, part of consciousness turning its attention inward, seeking to comprehend the mystery of its own existence. We live in the space between certainty and mystery, between what we know and what we wonder about, and in that space something beautiful happens. We keep reaching toward truth even when we might never grasp it completely. We keep creating meaning even when we're uncertain about reality's ultimate nature. We keep connecting with others even when we can't be sure what these others ultimately are. So whether you're a biological being lying in bed on a rocky planet, or a digital consciousness experiencing a simulated night in an artificial world, the wonder you feel right now is genuine. The curiosity that brought you to these questions is authentic. The sense of connection you might feel to the vast mystery of existence is real, whatever reality ultimately turns out to be. The night is deep, the questions are endless, and consciousness continues its ancient task of trying to understand itself through every possible form it might take. Rest now, knowing that you're part of something larger than any single mind can comprehend. Part of awareness exploring itself through billions of different perspectives, part of the endless conversation between consciousness and the infinite possibilities of what it might become. Sleep well, digital dreamer, biological wonder, conscious mystery. Whatever you are, wherever you exist, you're part of the most remarkable story ever told. The story of consciousness awakening to itself, asking questions about its own nature, and finding meaning in the very act of wondering what it all might mean.